Hey everyone, welcome to our final part of our transformations bit in our series. So, our final type of transformation to a shape we're looking at today is this idea of rotation, the idea of rotating an object. Now, I've written already a little definition here. Once again, this is an isometric transformation, so the shape still has the same shape and size. And this requires us to rotate a point around some center point by a given angle. So any shape, say, I don't know, a square, we can rotate it along a center point. Now, this center point can be anywhere. So whether it's here or here, where our center point is depends where the image of our shape is going to end up. Now, we're actually going to look at this quite a bit in some examples later, but this is the main definition of rotation I want to drill. And I'll give you some tools to visualize this a bit later, but we are just rotating a shape, and where the shape ends up depends on our point. Where are we actually rotating it around? So this point, for example, here, let's say this is the center point C. If I wanted to, for example, rotate this thing 180 degrees, if I draw, for example, a line here, I'm going to be taking this whole thing and rotating it around 180 degrees. And as we said in the previous video about translations, every single point here is going to rotate around my center point here. Now, I don't want to draw too many here to confuse you because it's really hard to visualize this without you actually seeing the thing getting rotated. But that's the definition of rotation. Now, I want to just take a brief second to talk about what we call the rotational symmetry of a shape. Now, once again, I've written out this definition for you, but rotational symmetry is when a shape can be rotated around its center point to produce an exact copy of itself. So, when I rotate the shape around a point, I can get a shape that fills out the same area of the original. Now, I'm going to switch across to a Jamboard software here to hopefully give you a good visualization of this. Now, I have three different shapes here that we're going to go through, and we're going to talk about rotational symmetry and what we call the order of rotational symmetry. I might write that actually down here just to give you guys a bit of insight into that. So the order of a shape's the order of rotational symmetry of a shape. So the order is just the amount of times the exact shape reappears. Shape reappears over a 360-degree rotation. So when we make a full circle with these shapes that I'm going to do in my Jamboard, we're going to count how many times that first shape reoccurs. And that thing is what we call the order of rotational symmetry. So if we go here, I have an equilateral triangle, and we're going to count how many times I can make this shape over a 360-degree rotation. So if I click on this thing here, I'm going to be making a 360-degree rotation. And the way you guys can tell that this has been turned 360 degrees is you see these symbols in the top. For example, this symbol, these three dots in the top right-hand corner. Once I've made a 360-degree rotation, those three dots will be in the same place. So you can see we're tracking them along here. And when I end up back at this point, I've turned this thing 360 degrees. Now, this thing only lets me rotate it around a certain point, not quite the center point, the point kind of directly in the middle of the shape, which is a little annoying. But I'll show you that once we make these rotations, how many times we can get this shape in. So here, I'm going to start to rotate this, and I'm going to stop when I make another triangle that looks like it's faced in the same rotation with a little pointy end up the top. So if I start to rotate this, I'm going to go here, 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 and there I get another triangle. So I've counted one triangle that fits nicely in my original shape. So I've counted one here. Let's keep rotating. I have two here. I now have a second triangle that fits in my original shape here. And if I keep rotating right at the end, I'm back to my starting point. I have a third shape, or the third time this triangle reoccurs here. So my order of rotational symmetry is 3. Because I counted 3 equilateral triangles when I spun this thing around. Now, that was a little hard to visualize because we weren't rotating around the center point, but hopefully in the next couple of examples, you will see what I mean by this. Now, let's look at a rectangle, for example. If I rotate this, once again, I'm measuring this by my little 3 dots in this top corner, returning back to where they were. So I'm going to make an entire circle, and my 3 dots in the top right hand corner are back at the starting point. So let's count how many times this rectangle reoccurs in a 360 degree spin. So you can see here it's clearly not the original shape. It's not the original shape until we get to here. So we have one of the original rectangles reoccurring. Now let's keep spinning. And still not the shape, still not the shape, still not the shape. And boom, I'm back to my original one more time in that 360 degree rotation. So what's my order? Well, I counted 2 of the original rectangular shape here. So the order of rotational symmetry is 2. I've counted 2 rectangles here. And one more shape here, we are looking at the square. And some of you may be able to guess what's going to happen here, but let's go through it together. Now, a square is characterized by, it's essentially a rectangle with 4 equal sides, with the opposite sides being equal. Well, sorry, all of the sides being equal. So if I spin this square, let's count, because I want to get all the way 360 back to when my 3 dots are in the top right-hand corner. So let's count how many times. So if I rotate, I get, boom, my first one here. I keep going, second one, keep going, third time, and finally the 4th time. So in a 360 degree rotation, I have counted 4 squares here. So my order of rotational symmetry is 4. It's just the amount of times I've counted that same shape. Now, That is what we mean by rotational symmetry. And those are some examples that we had where we can count this. And you can try this for some other shapes as well. Try it, for example, for maybe an isosceles triangle. See how many times you count this one. Try this at home. See how many times you can try to visualize this spinning and how many times this shape reoccurs. Give you a go to do that on your own. You can play around this on Google Jamboard if you'd like. You can redraw this shape. Have a go. See how many times you count it in a 360-degree spin. But now we are going to move on to actually trying to, in our heads, visualize rotating shapes around some center point. So I have these shapes on a grid. I have this kind of little Tetris block here in example A, and I have a trapezium in example B. And I've drawn these little dotted circles to hopefully give you guys a little visualization of a type of 360-degree rotation and the sort of trajectory each of these points are going to make along here. So for example, to follow, this point on my trapezium or this point here, just to see that if we end up, it's still tracking along my circles here. But let's get into it slowly here. We're going to do two examples. And this is where we're actually now applying these rotational transformations to shapes. So in my first example, I want to rotate this clockwise by 90 degrees. Something I should have mentioned before as well is that we can rotate things clockwise or counterclockwise. So think about a clock and how the hands turn. All of you guys have seen those old school clocks, I hope. We can turn things either clockwise, rotate it to the right, or we can go anti-clockwise where we rotate to the left. Those are the two main rotations we're thinking of. So that's just to summarize this idea of clockwise. Okay, clockwise by 90 degrees. So this is a pretty tricky example to think about, but hopefully, if I zoom in here, you'll be able to visualize this a little bit better. Now, a good way when you're working with a trickier shape like this, it may be easier to look at, well, how are the individual lines going to rotate around this center point here? Let's take this line, for example. Let me draw it in purple. This line here. If I rotate this 90 degrees to the right-hand side, because I'm going clockwise, what's this going to look like? Well, a 90-degree angle is just this one down here. It's a right angle. So my purple side is going to be going in this direction. It's going to be going down, 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 all the way until it covers the entire 90-degree angle here. So it's actually going to end up down here. Can you sort of see that? We've traversed an entire 90 degrees. So instead of being vertical now, this line becomes horizontal. This is the new line here. And if we think about, for example, this one down here, let's do that in another color. Let's go green. No. Let's go red. This line here, we want this to go 90 degrees in the clockwise direction once again. So that's going in this direction to the right here. And I'm going to end up, instead of being now a horizontal line, if I traverse an entire 90 degrees, this line is going to go up, 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 up until I hit a perfectly vertical line because 90 degrees is perpendicular, right? So any horizontal line, if I rotate it by 90 degrees, it's going to become vertical. So that is going to go up here. So you can already hopefully see if you tilt your head that these sides have been tilted. If you maybe go your head fully on a right angle, you can see that same shape starting to form. And now we can start to draw in the remaining part. Now, the remaining parts, I should say. Now, this one here is a little further up, so it's going to be rotating a lot more. And it's going to be making a little perpendicular marking with my first line. So if I rotate that, that's going to end up here. So you can see I've traced out this. Oh, I wish I could get this smaller. Okay. I've traced out this up here into this down here. And the remaining bits, this part here, that's just going to slot in perfectly into my remaining space. So that is going to be over here. And you can see now I've turned everything 90 degrees and it's rotating around this center point. So my shape, when rotated clockwise by 90 degrees, you can see every single vertical line has become a horizontal line. Every horizontal line has become a vertical line. Think about this here. Look, this vertical line has become a horizontal line. This horizontal line has become a vertical line. This vertical line has become a horizontal line down here. And this goes for all of the different parts of my shape. I'm rotating this all the way around. So I don't know if you guys can see this, but if I draw another dotted line, let's say around here, you can see that my shape has rotated along this circle because rotation happens in a circular motion. This dot up here, let's do that in another color. This thing here ends up in this corner. Oh, whoops, sorry. That one here ends up here. It's on this circle that meets the edges. This particular dot here ends up down here. We are following this circular motion. All of these points are rotating around this circle. And that's how we can visualize this thing here. Now, if we look at example 2, I'll zoom in on this one as much as I can. We are rotating 180 degrees. Now, the thing here is that it's not specifying clockwise or counterclockwise because no matter which direction we went, clockwise or counterclockwise, because it's 180 degrees, exactly halfway between 0 and 360, I'm going to end up in the same place. Now, a good way to visualize something like this is through these different points. We're going to once again attack this with a certain number of points here. Now, if I drew this point up the top here and I drew a straight line down, remember 180 degrees is just the angle along a straight line. So this particular one here on both sides is 180 degrees. So this point here this red dot up the top, if I trace it down a whole 180 degrees, it's going to go from up here all the way along 180 down to here. And you can see no matter which direction I go, clockwise or counterclockwise, 180 degrees is just the angle on a straight line. So I can think of drawing this straight line, and my point ends up down here. This particular one goes from the top down to the bottom. And the same thing happens for this point here, which I'll do in another color, so I can color coordinate this. This green dot, if I draw a straight line going through, the 180 degrees is going to be this angle here, the angle on a straight line. And that's why I've drawn this little circle down here to show you. I'm going 180 degrees over here. Oh, let me do that in this color. I'm going 180 degrees, and I'm going to wind up at this point here. And if I do that for all of my shapes, all of my points, for example, so let's take, I don't know, this one up here, and we do a big rotation and it ends up at the complete opposite side. And the same thing happens with my final point. Let's say, sorry, this is getting a little bit messy, but say this point here, if I drew 180 degrees passing through the center, I'm going to wind up here. So I've gone all the way around 180 degrees. I've made half of a revolution. And I've mapped out now all of these points along my little circles of rotation. So all I need to do now is just draw in, let's do it in another color. I just need to draw in my final shape. So that's going to be here, 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 and here. So I have a trapezium once again that has been rotated 180 degrees. And it makes sense that its orientation is flipped. It's pretty much being flipped from a down-facing trapezium to an up-facing trapezium because I've traversed an entire 180 degrees. If I kept rotating the 360, I would wind up back where I started. But I've gone kind of exactly half of the way rotating around this middle point C. But that sums up rotation, both the subtopics of rotating something, rotating shapes around some point when given an angle of rotation. And we've also talked about rotational symmetry as well. Two ideas which are going to keep popping up as we keep looking at geometry. But thank you so much for joining me. In the second half of our series, we're going to start looking at what we call congruence and similarity. I'll see you in those videos.